When we talk about road construction, most of us immediately think of concrete, steel, and asphalt. Materials that are hard, heavy, expensive, and leave behind a massive carbon footprint. But in some rural regions of India, people are doing the exact opposite. They are building roads with a material that is soft, lightweight, derived from nature, and most importantly, biodegradable. That material is core geotextile fabric. It sounds almost unbelievable. A fabric made from coconuts becoming the foundation for trucks, heavy machinery, and millions of journeys every year. Yet it is precisely this contrast that makes the solution so remarkable. In this video, join Terran Works as we follow the entire journey, from coconuts growing on trees, through industrial processing lines, to their final role as a quiet, unseen layer supporting an entire road network. You know, the lifespan of a road does not depend only on the asphalt or concrete you see on the surface. What truly determines how long it lasts lies hidden deep underground, in a layer so thin that most road users never realize it exists. If this layer fails, the entire structure above it will eventually crack and collapse. Core geotextile fabric is precisely such a layer. It is woven entirely from natural coconut fibers, containing no synthetic plastics, no artificial polymers, and no petroleum-based materials. Its entire structure originates from a single biological resource, the coconut husk. In civil engineering, geotextiles are not secondary materials. They are placed between weak subsoil and the structural layers above to perform critical functions, controlling water flow, stabilizing the soil base, distributing loads, and preventing erosion. It is no coincidence that core geotextiles are so widely used in India. The country brings together all the conditions that make this bio-based material especially suitable. Weak soil foundations across many rural areas, a tropical climate with heavy seasonal rainfall, and an enormous demand for road construction, while infrastructure budgets remain limited. Instead of relying on imported polymer geotextiles, India makes use of its own abundant natural resources. The journey of core geotextile fabric begins in coconut plantations stretching across southern India, a region that accounts for more than 60% of the country's total coconut production, with over 19 billion coconuts harvested each year. In the year-round hot and humid tropical climate, coconuts are more than just a crop. For local communities, they form a complete economic ecosystem, supporting millions of livelihoods across industries, ranging from food and beverages to construction materials. Coconuts are typically harvested at around 11 to 12 months of age, when the husk is mature enough to produce long, strong fibers, rich in lignin. On average, a mature coconut tree yields between 50 and 80 fruits per year. And on large plantations, harvesting takes place continuously in 30 to 45-day cycles to ensure a steady supply of raw material for processing facilities. The most common harvesting method still relies on manual labor. Skilled workers climb coconut trees standing 8 to 15 meters tall without safety harnesses, cutting down entire bunches and allowing the coconuts to fall freely to the ground. Each coconut can weigh between 2.5 and 3.5 kilograms, so the area below must always be kept clear to prevent damage and accidents. In areas with difficult terrain or exceptionally tall trees, workers use long cutting poles measuring 8 to 10 meters to harvest from the ground. While this method is safer for laborers, it causes coconuts to hit the ground with greater force, increasing the risk of impacts against rocks or roots, which can crack the husk and affect the quality of the coconut meat. Immediately after harvesting, the coconuts are gathered at collection points within the plantations or along major roads, where the husks are separated as the next step in the process. Once mature coconuts are harvested, the most valuable part for the geotextile industry is not the coconut water or the white flesh inside. What is retained is the thick outer husk surrounding the fruit, typically 5 to 7 centimeters thick and accounting for about 35 to 45% of the coconut's total weight. Within this husk are millions of fibers bound together by natural lignin, forming a structure that is tough, durable, and resistant to biological degradation, key properties for load-bearing and erosion control in construction. The husk separation process still relies heavily on manual labor. Coconuts are secured onto metal spikes or pointed stakes, and workers use specialized knives to peel away sections of the husk from the hard inner shell. A skilled laborer can dehusk between 500 and 1,000 coconuts per day. And at large collection centers, hundreds of workers can process tens of thousands of coconuts daily. At this stage, the coconut husk is still rough, moist, and completely unsuitable for construction use. Yet within this seemingly low-value material lies an enormous fiber potential, the foundation for the entire downstream processing chain, and the starting point for roads that will endure decades of harsh sun and rain. After being separated from the fruit, coconut husks are still nothing more than a raw, heavy material with a very high moisture content, often exceeding 60%. In this condition, feeding them directly into machinery would cause the fibers inside to break, tangle, and lose the tensile strength required for later stages. For this reason, the next step is almost impossible to skip. Natural drying. The husks are spread out across open drying yards, left fully exposed to sunlight for 2 to 4 weeks, depending on weather conditions and the season. This slow drying process gradually reduces moisture content to around 15%, while also softening the natural lignin structure, creating ideal conditions for mechanical fiber separation. Once the husks reach the appropriate level of dryness, they are fed into fiber extraction machines. Inside the system, rotating shafts and rollers tear apart the husk, freeing long coir fibers from pith and impurities. At this point, a clear stream of coarse fibers has formed, ready to move on to the next stages of processing. After fiber extraction, coir still retains a certain amount of moisture and can easily develop mold if stored for long periods. To prevent this, the fibers are dried further for 3 to 7 days, reducing moisture content to below 5%. This is a critical threshold that makes the fibers lighter, more stable, and suitable for long-term storage without compromising their mechanical properties. Once the fibers reach the standard level of dryness, they move on to the spinning stage. Spinning machines operate continuously, straightening and twisting the loose fibers into uniform strands with consistent tensile strength. This step not only prevents the fibers from tangling or breaking during weaving, but also directly determines the load-bearing capacity of the finished geotextile fabric. Once the coir fiber bundles have been fully dried and stably twisted, they enter the final forming stage, weaving into geotextile fabric. In industrial weaving facilities, the fibers are wound onto large spools and fed into specialized looms. The warp yarns are stretched in parallel to form the primary load-bearing framework, while the weft yarns are interlaced at regular intervals, creating the characteristic mesh structure. The looms operate continuously, producing an average of 200 to 300 meters of fabric per hour, depending on the weaving density. Mesh openings typically range from 10 to 25 millimeters, large enough to allow rainwater to pass through while still maintaining soil stability. On average, 100 kilograms of coir fiber can produce approximately 250 to 300 meters of fabric at a width of 1 meter. Alongside industrial production, coir geotextiles are still woven by hand in many rural areas of India using simple mechanical looms. Here, the entire process relies on the skill and experience of the weaver. From setting the tension of the warp fibers and controlling mesh spacing to maintaining a steady rhythm while passing the weft through the frame. Hand weaving delivers much lower output, often only a few dozen meters per day, but offers high adaptability to specific terrain conditions and use cases. After completion, the fabric is inspected for quality, rolled into large coils, and prepared for transport to construction sites. When rolls of coir geotextile fabric leave the factory and arrive at the construction site, they enter the most critical stage of their journey, becoming the quiet foundational layer that supports the entire road structure above. Before the fabric is laid, the subgrade is leveled and thoroughly compacted to remove uneven spots, sharp stones, or hard objects that could damage the fiber structure. A stable, smooth base is a prerequisite for the fabric to perform its engineering function properly. On site, the fabric rolls are placed at the starting point and unrolled along the center line of the road. The fabric is laid flat, pressed tightly against the soil surface, with no folds or gaps. At joints, the edges of adjacent sheets are slightly overlapped to form a continuous layer, ensuring that loads and water flow are evenly distributed from the foundation upward. The fabric is then temporarily secured with stakes or pins, just enough to hold it in position during the next construction steps. Once the geotextile layer is in place, successive layers of gravel, soil, and crushed stone are spread over it and compacted to form a solid base before final steps such as asphalt paving. Thanks to this reinforcement layer, the road above gains greater load-bearing capacity, develops fewer cracks, and maintains a longer service life, even under harsh climatic conditions. While coir fibers become the foundation for roads, the white flesh inside the coconut opens up an entirely different value chain. After dehusking, coconuts that meet food-grade standards are sent to coconut oil processing facilities. The flesh is grated, washed, and dried, then extracted through mechanical pressing or cold pressing to obtain virgin coconut oil. This process is designed not only to maximize yield, but also to preserve the natural aroma and biologically valuable fatty acids. Coconut oil is widely used across food, cosmetic, and pharmaceutical industries, from cooking oil and skincare products to soaps and bio-based lubricants. In India, it is one of the highest value products derived from coconuts, contributing significantly to the income of growers and processing plants. Notably, even the coconut cake left after oil extraction is not discarded. It is further used as animal feed or organic fertilizer, closing yet another loop in the material cycle. Alongside coconut oil, whole fruit coconut water is rapidly emerging as a high-growth value stream in the modern coconut industry. Immediately after harvest, young coconuts that meet quality standards are carefully selected, surface cleaned, and hygienically treated to preserve their natural shape. Instead of being opened or extracted right away, the coconut water is kept intact inside the shell, after which the entire fruit is chilled or lightly pasteurized to extend shelf life while maintaining its fresh taste and natural mineral content. In modern processing facilities, whole coconuts are sorted by size, labeled, wrapped, or packed into export cartons, with throughput reaching tens of thousands of fruits per day. These products are widely exported to Europe, the United States, and the Middle East, where consumers value the experience of drinking directly from the coconut as a symbol of natural, minimalist beverages with minimal industrial intervention. From whole fruit beverages and coconut oil to construction materials, coconuts in India do not follow a single path. Instead, they branch into multiple parallel value streams, each serving a different industry, yet all originating from the same familiar agricultural resource. From a discarded byproduct left on the edges of tropical plantations, coir fiber has traveled a long way to become the silent hero beneath the roads we use every day. The story of coir geotextiles is not just a story about civil engineering. It is a powerful reminder that humanity is learning to return to nature in search of solutions for the future. As we confront climate change and the depletion of fossil resources, these rough fibers remind us of a simple truth. Sometimes, the most advanced solutions are also the simplest ones, hidden within the husk of an ordinary fruit. What do you think about replacing plastics with natural materials in heavy industry? Could this model be applied to other crops as well? Share your thoughts in the comments below, and don't forget to like and subscribe to Terran Works as we continue exploring more remarkable journeys in our upcoming videos.